All right, here we're looking at section 2.5, and our big essential question is how can you use inequalities to describe intervals on the real number line? Because we've been looking at some inequalities, but we've been looking at some simple ones. So now today we're going to be looking at compound inequalities. And that's our first learning target, is to write and graph those compound inequalities. Then we're going to be solving some of those compound inequalities, and then we're going to be looking at some word problems, some real life problems with those compound inequalities. So the first thing, a compound inequality is where we have an and or an or. Those are going to be our two statements. We've been just dealing with simple inequalities. Now we're adding some more in. So one thing we notice is we have that and or, our graphs look slightly different. So when we're talking about an and, we can graph each piece that we get, each solution and each part of the inequality, and we want to see where they overlap. So when I have the word and, that's where they overlap. Okay? So when I see the word or, that is any place that either of them touch. And we'll see some of these in our graphs and when we're working on homework, that this graphing them can really help us see where they all touch. Okay? So just remember that an and is where my graphs overlap, and an or is either of the answers. Okay? So first we have to write them down and then graph them. So the first thing is a number x is greater than -8 and, there's my key word, less than or equal to 4. So I want to look at them in chunks. So a number x is greater than -8, so I can write that inequality, and then I can write the inequality for less than or equal to 4. So that's what that looks like. So the cool thing when I'm dealing with and statements is I generally am able to write them in one sentence. So here I can see that my arrows can both go the same direction, so I can rewrite my inequality. So -8 is less than x, which is less than or equal to 4. So I always want to write my and statements where this is the lowest value possible and this is the highest value possible, and my variable is in the middle. So then when I graph it, I just graph the intersections, so where they overlap. So I would graph that -8 is less than x, so it's an open circle on -8, and then it's less than or equal to 4, so it's a closed circle on 4. And this is an and, so this is where they intersect and where they meet. So now let's look at B. So I have a number y is at most 0, or there's my keyword here, at least 2. So I can go ahead and write both of those pieces. So with an or statement, I can't combine them. So now I can just have that as my final inequality, and I can graph those separate pieces. So I just graph that y is less than or equal to 0, or y is greater than or equal to 2. So I go ahead and include both of those in my graph. So now we're going to solve some of these inequalities. Okay, this is that second learning target. So you've learned often that what you do to one side of the equation you have to do to the other. But in reality, it's what you do to one piece you have to do to all of the pieces, and that will keep us going. So here, with this first one, I want to get x by itself, right? That's always when we're solving, we want to get the variable by itself. So in order to do that, I want to add 2. But I don't want to add 2 just in the middle. I have to add 2 over on this side, and I have to add 2 over on this side. So now I end up with a -2 is less than x, which is less than 5. This is going to be my final inequality. So now I can go ahead and graph that, okay? And one thing I notice is that this is a one statement with my variable in the middle, so this tells me that this is an and statement. So I can go ahead and graph these. So 1, 2, 3, 4, 5, 6. Oh, and it's a -2. Never mind. Let me erase these a little bit. Okay. So we're going to add a little bit more to my graph. So I've got that -2, -1, 0, 1, 2, 3, 4, 5 is right there. So here I see I have an open circle on my -2, and x is greater than that, so I'm going to be shading this direction. Okay. So then I also see I have an open circle on 5, and I'm shading this direction. The place where my graph overlaps is from -2, and then I'm shading an open circle on 5. So this is what my final graph would look like on that number line. So now let's look at this second equation. So again, what I do to one piece I have to do to them all. So here's my x in the middle, and I want to solve for that x. So I start by subtracting 1 from each piece. So now I have -4 is less than -2x, less than or equal to 8. So now I have to undo this multiplication by division. But here I'm dividing by a negative number. And remember that when I divide by a negative, I have to switch the direction of the signs. So here, since I have two signs, I have to switch the direction of both of them. So now I can just simplify. So negative 4 divided by negative 2 is 2. Here I'm left with x. 8 divided by negative 2 is a negative 4. Well, this is harder for my brain to handle because I like things to be in numerical order. So I'm just going to reflect this so it looks more like the number line. So I've got my negative 4 towards the small side of that sign, x, and then less than 2. So now again I see this is an and statement. Since it's one statement, and I can go ahead and graph that. I can graph where they intersect. So 2, 1, 0, here's negative 2, negative 4. So here I have a closed dot on negative 4 and an open dot on 2, and I'm shaded in between these two. So that's solving and graphing these and statements. So now let's look at this or statement. So when I have an or statement, I'm always going to have two different pieces to it. So I can solve each piece individually. So I start by adding 5 to both sides, and I'm just looking at this first piece of my or statement. So I end up with 3y is less than negative 3. Now I'm going to divide by 3 to get y by itself. Since I'm dividing by a positive number, I don't have to do anything to my signs. So now I've solved for y. So now you have to look at the second piece of the or statement and solve for the y there. So I add 1 to both sides. So 2y is greater than 6. Again, I divide by that 2. Since it's positive, nothing changes. So here are my two statements that I'm going to be graphing, right? So this is my or. So y is less than negative 1 or y is greater than 3. So let's look at this on our number line, because we always want to graph it using our number line. So there's 0 and 5, negative 5. So here I see I have y is less than negative 1, so I can put my open circle on negative 1 and I'm shading this way because y is less than. Okay. Then I also see I have y is greater than 3. So again, I have an open circle on 3 because I don't have an equal to, and I can graph and I can shade to the right because it's greater than. So now I'm looking at my or and see that they're going in opposite directions, and that looks like a pretty good graph to me. So here are some I want you to try. Definitely try solving for them first, and then see what the graph looks like. See if you can notice any patterns. So now here's that real world problem. And now we all know this is true, that electronical devices don't work very well if they're super hot or super cold. Like in the middle of winter, if you leave your computer in your car overnight, it's just not going to work so well in the morning. So I have a specified temperature that I can operate in. And here, I'm told my operating temperature in Celsius, right? So it works between 0 and 35 degrees Celsius. Well, that doesn't make much sense to me because I generally live in Fahrenheit. So let's go ahead and convert that to Fahrenheit. So here's that equation that we've used before, one of those common ones that we're going to use often. So I can just replace that. So I have 0 is less than or equal to 5/9 times f minus 32, which is less than or equal to 35. So I haven't changed anything yet. I've just replaced my Celsius with my equation for Fahrenheit. So now let's go ahead and solve for that Fahrenheit. So the first thing I want to do is multiply by 9 to get rid of that fraction. So I end up with 0 is less than or equal to 5 times f minus 32 is less than or equal to 405. So now to get rid of the next piece, I have to divide by 5, divide by 5, divide by 5. So I have 0 is less than or equal to f minus 32, which is less than or equal to 81. So now my final step to get f by itself is I can add that 32 to all of my different pieces. So I end up with 32 is less than or equal to f, which is less than or equal to 113. So now I just want to stop and think, does my answer even make sense? Well, for me this makes sense because this is freezing, and I know that my phone and my computer don't work very well when I'm below freezing. And then I know that If it's 113 degrees, which the inside of the car gets to be sometimes in the summer, things don't work as well either. So that actually makes sense, right? I don't have to go back and double check everything. I just have to see, does my answer make sense? So then up here, we're asked to describe one situation where that could happen. And you have many of those situations, right? It gets very cold in the winter here, and in your car in the summer it gets really hot. Or if you're in Phoenix, that's another situation where it could be over the temperature that it works very well. Okay. So now in your book there's a pair of winter boots that also have a temperature rating. So go ahead and try that one. So now we've actually gone through everything. So let's double check our learning targets. So first we had to write and graph compound inequalities. So we want to take them from words and then write the inequality and then be able to graph it. Then solving inequalities, and remember if we have an and or an or, what that looks like. And also that what we do to one thing, we have to do to all of the things. Then we use some compound inequalities and some word problems and those real life problems. So now that we've gone through all of these, go ahead and work on your homework for this section.